Since his earliest beginnings, long before the days of the Bible, man has looked to nature for his needs and his comforts. Here in the Middle East, the fruit of the date palm has served for thousands of years as a basic food supply. Its commerce throughout antiquity led the caravans to ply their historic trade routes from Riyadh to Jeddah. Less than 50 years ago, the discovery of oil brought new opportunities and a new way of life to this ancient land. Men left their caravans to learn new jobs, and change came to half-forgotten cities. In Central Europe, too, the growth of towns and nations was traditionally built on the yield of the soil. Broad fields of flax provided the basis of North Europe's flourishing textile industry. Today, oil and natural gas have wrought changes, laying the basis for a new and higher standard of living throughout Europe. And far to the west, off the coast of the Americas, in the azure blue waters of the Caribbean Sea, the people of Venezuela have for centuries found food and natural wealth. The oyster beds of the Margarita fisheries were rich with pearl oysters. Centered around these precious gems was the economic life of hundreds of villages, thousands of people. Then, less than half a century ago, oil joined the Venezuelan economy. One well became 10, 100, then thousands. In Latin America, in Europe, and the Middle East, anywhere in the field of construction, engineering, and contracting for the oil industry, one name came to the fore. Few cities in the world have played a larger part in the development of the petroleum industry than New Orleans, Louisiana. Both the city and the state have contributed much. While preserving its past in the old French Quarter, New Orleans is nevertheless a modern and enterprising community. One of the city's largest and most dynamic business firms is the McDermott Company. With headquarters for field operations here in the Crescent City, it is a globe-spanning organization with oil engineering and construction interests in many parts of the world. Typical of its work is the Superior Oil Company of Venezuela's Flow Station Number 1 in Lake Maracaibo, which processes 55,000 barrels of oil a day. Because of the success of this project, the Venezuelan Sun Oil Company, the operating partner and co-owner with Texaco Seaboard Incorporated and Venezuelan Atlantic Refining Company, invited representatives of McDermott to consider plans for building the largest and most modern flow station ever conceived. This initial meeting would mark the start of one of the most significant stories in the history of the petroleum industry. To these representatives, the Sun management presented its specifications. A single flow station, which would have the largest throughput ever, 100,000 barrels separated and pumped every day. Moreover, as envisioned by Sun's management, the flow station would be electronically automated and self-controlled. If the answers to these complex problems could be found, the installation would be a landmark in the history of oil industry progress. All the information gathered at the initial meeting with the Sun management in Venezuela is promptly relayed to McDermott's headquarters in New Orleans. Here, various engineering specialists gather to be briefed on the general characteristics of the flow station desired by the oil company. Because of the intricacy of design, careful pre-planning will be a vital element in the success of the project. 4 weeks after the meeting in Venezuela, detailed engineering plans are well underway. The specifications being prepared will not only spell out the design of the revolutionary new flow station itself, but also for the procurement, fabrication, and installation of the entire complex of machinery. Scores of draftsmen devote full time to this single project, and often far into the night. All are well aware that this is one of the most significant projects ever tackled by the company, that they are working on a precedent-setting installation. All in all, there are some 600 drawings involved. After 6 weeks of intense work, 3 fat volumes of specifications are the end result. At the same time that the specifications are submitted to Sun's management, simplified drawings are presented to show as graphically as possible how the entire installation will be integrated with already existing facilities, how the plans allow for additional flow stations to be added to the field in the future. Erected on an aluminum structure, the electronically automated production flow station will be capable of handling 100,000 barrels of oil per day with only mechanical supervision. Simultaneously, a junction platform will be erected a mile away. This junction of the lines from the flow station is the takeoff point for the 35-mile pipeline to shore. Further, it was proposed to construct and install wellhead facilities on each well platform, to lay the flow lines from the wells to the station, to construct and lay the 14-inch gathering lines from the flow station to the junction platform, and to construct and lay the 35 miles of main 18-inch pipeline in 90 feet of water to the tank farm ashore. All in all, a monumental undertaking. After several additional meetings, when new refinements are discussed in the list of specifications, Sun gives McDermott the order to go ahead to handle the entire project from the design and fabrication in the United States to installation at the work site in Lake Maracaibo. 7 days later, at the company's Bayou Buff plant near Morgan City, Louisiana, the fabrication of the aluminum structure is started. This large diameter aluminum pipe has been formed on the rolling mill from 3/8-inch flat plate here in the plant. The caisson, an integral part of the structure, will be built in similar fashion. At the same time, in another part of the yard, work on the flow station itself begins. Among the first pieces fabricated are the flanges for the risers, which will hook up with the flow lines of each well. Because of the thousands of parts and miles of wire to be incorporated in the giant piece of machinery, a finely drawn timetable is established to coordinate the installation of the various elements at the work site in Lake Maracaibo. Early the following spring, the first sections of the installation are ready for shipment to Venezuela, exactly on schedule. Among the first pieces of equipment shipped is the aluminum foundation, the underwater platform on which the flow station will rest. Contained in it is the caisson or surge tank, which will receive the oil from the separators. The caisson marks a great advance in flow station design. Being under the platform, with an opening in the bottom of the tapered cone, the oil in the caisson is supported by the waters of the lake, thus relieving the foundation of the weight of the oil. Days later at Maracaibo, the structure is ready for installation. The use of aluminum is a feature of McDermott's Venezuelan operations, making the company a leading fabricator of heavy welded aluminum structures. The highly corrosive water conditions found in Lake Maracaibo have plagued drilling and producing operations for 30 years. A few years ago, engineers of Reynolds Metals Company and McDermott worked worked together to design a deep water platform that would have the structural strength of steel and yet be completely corrosion resistant. The result? A metal structure with underwater lateral bracing down to the lake bottom, which will resist corrosion indefinitely. Here is the installation of the foundation as it would appear from under the waters of the lake. Once the aluminum jacket has been placed in position and leveled, steel piles are inserted in the hollow legs to anchor it to the bottom of the lake. At the same time, nearby, the marine pipeline crew is at work laying the 35-mile pipeline to shore. This is a job requiring a tremendous amount of heavy, specialized equipment. The pipe has been coated on shore with enamel to prevent corrosion, and then overcoated with concrete to eliminate flotation. These welders on foreign duty are a special breed, taking pride in every bead of every weld. As the lay barge is eased slowly ahead, the end of the line is submerged in the water of the lake. Because of the water depth and the weight of the pipe, a buoyant support 265 feet long is used to ease the stress in the pipe as the line is lowered to reach the lake bottom 90 feet below. Back in Louisiana, meanwhile, on June 1st, 1959, the superstructure of the flow station is ready to be moved from the mill building to a waiting barge. To date, 50,000 man-hours have gone into the construction of this engineering complex. All the delicate instrumentation and machinery, pumps, valves, and generators have been polyethylene coated to prevent salt spray damage during the voyage ahead. A great deal of planning has gone into the loading of the barge. Distribution of weight and balance are a vital concern to ensure a safe, successful trip. The color coding of the piping denotes the different fluids which will flow through the arteries of the system. The meticulous loading procedures have taken 3 days. Now, on the 4th of June, the flow station sets out for Lake Maracaibo, behind the tug Rosalie, aboard the seagoing barge Venmac II. It will be a trip of 1,900 miles from Morgan City, Louisiana to the lake in Venezuela. For 2.5 weeks, the precious cargo will be under tow. Aboard also are 2 aluminum drilling platforms for other jobs in the Maracaibo area. Still stateside, meanwhile, in Houston, Texas, an important subcontractor, Texas Instruments, has been at work around the clock on the mechanical brain for the flow station. Frequent visitors to the Texas Instrument plant are McDermott engineers keeping abreast of the work in progress. As the completion date of the electronics instrument package nears, McDermott and Texas Instruments engineers, scientists, and technicians maintain close liaison. Every circuit is checked time and again to eliminate any chance of malfunction once the control center leaves the shop. Thanks to the example of the best in present-day electronic controls, the entire sun installation at Lake Maracaibo will be controlled automatically and will have a central data gathering point on the junction platform. Finally, another piece of the complex mechanical puzzle has been put in place. While Venmac 2 is en route to Venezuela, and while the finishing touches are being put on the control apparatus in Louisiana, dozens of technicians and engineers are being processed for overseas service in the McDermott dispensary. Because of its long experience in foreign construction work, the processing is handled as a simple matter of routine. By air, 7 hours away from New Orleans lies Maracaibo, a cosmopolitan city which a few years ago was little more than a crude village. Less than a year after the initial meeting with Sun Oil's management, the first contingent of specialists from New Orleans arrives at the Maracaibo airport. Arriving simultaneously with the advance party is the electronic control equipment manufactured by Texas Instruments. Each box is handled with utmost care. Now the flow station starts the last leg of its journey. Workmen have already left aboard the derrick barge.
A derrick barge at night is really something to look at, unless you're on it. Then you've got other things on your mind. Like your part in the job that starts as soon as it's light enough to see. That aluminum jacketed structure has been waiting there for us for a month. We've been waiting too, since before sunup. Nobody sleeps late on a derrick barge. When the flow station comes alongside on Venmac 2, it's in place and on time. There's work for all hands, Venezuelan and American, and for all heads, too. The lifts go on one at a time. When we're finished, 5 of them will be piled more than 83 feet high, just about as tall as an 8-story building. The first one is the 100-ton caisson deck, the section that holds the slop pumps, the caisson metering equipment, and the flow line origin points. This is where the lines from 46 separate well completions will tie onto the flow station. Watch those hand signals. Every one has meaning to the barge captain who relays them through his own hand signals to the derrick operator, key man in one of the trickiest of all construction operations. No room for guesswork, no place for amateurs, no margin for error. Everything has to fit. The first lift always sets the pace in the station system, using as fuel natural gas that is separated from the crude oil flowing through the station, or that will flow through the station once we get it put together. At the same time we're working on the flow station, another crew a mile to the west of us is working on the junction platform. This is where the pipeline carrying separated oil from the flow station will junction with the main line that carries it 35 miles to the tank farm on shore. After the platform is finished, it will have 2 more decks, with a warehouse for spare parts, living quarters for a maintenance crew, and a landing pad for helicopters. All the comforts of home, plus provisions for several more pipelines from flow stations which aren't even started yet. It's not quite noon now back at the flow station, and we're ready for the 3rd lift. This is a light one, the separator deck, only 32 tons. The separators themselves come later. With the deck in place, it's welded off, so that each supporting leg becomes a single solid column. Almost an hour later, we're ready for the next lift, number 4, the first of the 2 banks of separators. It's routine and it's simple, involving just a spreader bar weighing about 8 tons and some cable and shackles. That pale green control room in the separator bank is where the instrument panels and electronic control gear will go when the job is completed. When it is, the electronic brains and mechanical muscles will take it over and run it almost by themselves. They're great things, all right, when you stop to think about it. A bunch of machines running something as complex as a flow station. But it'll be a long, cold day before they can take the place of men when it comes to building one. By the middle of the afternoon, we're ready for the fifth and final lift, the second separator bank. This unit houses the high and low pressure separators. The test separator is in this unit too. The special test system that can single out any one well and give it an individual performance checkout. Then after testing one well, it can move on to test the others one after another without disturbing the regular production of the other wells running through the other separators in the bank. Well, that's it. 30 hours from the time the derrick barge first moved in alongside Venmac 2. Less than a day and a quarter for a job that could have taken 3 or 10. Maybe it's some sort of a record. We don't know. We weren't working for a record. We were building a flow station. In any case, it's up and it's ready for the next step. And for the Texas Instrument boys who are right behind us.
We engineers from Texas Instruments have a pretty elaborate job to do, too. Before connecting a single wire or transistor, we've got to check every unit of the complex apparatus to make sure there's been no damage during shipment between shore and the worksite. When assembled, the control unit will form the brains and nervous system of the entire installation. Through automation, it will monitor the pressure and flow of oil from each connection and will shut in a well and sound an alarm on the junction platform if anything goes wrong in the separating or pumping processes. Each of these multiple circuits controls a single well. Essentially, automation means greater efficiency and economy in the entire operation. At the flow station, we finally unpack the electronic components for the control panels.
But regardless of what anybody else is doing, it's still McDermott's baby till it works, until we turn it over to the customer. It's our electrical engineers who must examine all the circuits between the flow line control valves and master control, and who are responsible for okaying them. Altogether, the hooking up operation takes us about 6 weeks. One bad connection, one badly adjusted valve, can throw the whole system out of kilter and start a chain reaction of trouble. There are more than 2,400 electrical connections to be tested, and something over 3,000 engineering checks that have to be made before we can start operating. Not counting checks and tests at the junction platform, that is. Tests here show us that all the valves are operating, and that they're set correctly to assure an even flow without a break from the flow station all the way ashore. The big moment, August 12th, 1959. But it's got to be a slow big moment. The job started February 1st, and it was finished on August 12th. 6.5 months from the start of construction to the opening of a working installation more than 1,900 miles from the fabrication shop back home. And it is a working installation. After 6 weeks of manual operation, handling 25,000 barrels a day, it will be ready to move into high gear for the automatic handling of 60,000.
We Texas Instrument men have to make one final test, a check on the taped record of the flow station's performance kept by the control center. After a prescribed length of time, the punch tape from the recording machine is picked up at the flow station for delivery to a translating machine ashore. Eventually, this hand-carried method will not be necessary. Soon, the memory unit or command will put itself on radio and broadcast its information to the data translating machine. The memory unit will transcribe information on one tape for 30-day periods. Temporarily, during these first test phases, the translating equipment is housed ashore in Maracaibo. The taped record is fed into a teleprinter, which types out production data for a day, a week, or a month. Vital information, once passed on by telephone, is now handled by electronics. The data processing machine reports figures compiled by our checkout engineers in the field. From separators to caisson, from pump deck to junction platform, the entire installation is functioning smoothly.
Today, Sun Oil's flow station number 1 has a rated capacity of 100,000 barrels a day throughput. Oil is being pumped into the tank farm at Punta de Palmas on the shores of Lake Maracaibo. Tanks like these hold 180,000 barrels apiece. From all over the world today, tankers come to Lake Maracaibo to take on cargoes of crude oil pumped from underwater reservoirs. As part of its job here in the rich Venezuelan oil fields, McDermott has designed and installed special mooring buoys, which enable tankers to load from submarine lines far offshore. Often, the tankers need not put into dock or wharfside to take on their cargoes. And from Maracaibo today, tankers leave with thousands of barrels of crude produced through this unique installation for ports the world over. Rarely in oil field construction history has so much been accomplished in so short a time. This flow station is truly a testament to one organization's experience, skill, and versatility. Here now in the heart of Lake Maracaibo rises an artificial man-made island, an automatic processing plant which works 24 hours a day, 7 days a week. Sun Production Island number 1. A pioneer in the development of the jacket-type drilling structure, the company has erected over 75% of all those in the Gulf of Mexico. The unique design and method of bracing enables these structures to withstand tremendous loads. Under tow here for installation at a Gulf oil drilling site is a 230-foot structure, the tallest of its kind ever built. At the start of the installation, the structure is lowered into the water in a horizontal position. When drilling starts from this completed structure, a new record for deep water drilling from a fixed platform will be established in the Gulf. The installation is being made in 205 feet of water. The structure is rotated to the vertical position, and after piling is driven through the legs, installation of the drilling equipment begins. At the same time, in the Louisiana marshes, McDermott suction dredges are busy on inland drilling locations for many different companies. Far to the south in Argentina, work is underway on a long crude transmission line from the Comodoro Rivadavia oil field to the Atlantic coast. An additional 25 miles of 6, 8, and 10-inch gathering lines will be laid in this oil field for the Pan American Argentina Oil Company. In times of emergency, almost anywhere in the Gulf, McDermott's barges are the first pieces of equipment arriving to serve as bases for fighting oil well fires. The company's engineering and contracting interests extend far beyond the oil industry. Pipe laying of all kinds is within McDermott's sphere, such as this underwater molten sulfur line for the Freeport Sulfur Company. This multiple 7-mile pipeline was made up on a 2,000-foot long pipe rack. from which it was launched into the Gulf of Mexico. Here it will connect with a structure which, when completed, will be the world's largest steel island. This section of a deck alone, just being lifted into place, weighs 650 tons. At any given time, the company's tugs and barges may be found heading for a variety of different work sites around the world. To the Persian Gulf off Iran for Pan American International, to the Gulf of Paria off Trinidad for Dominion Oil Limited, to the Gulf of Campeche off Mexico for the Pauly Pan American Petroleum Company. Because of its accomplishments to date, the company can well be proud of its part in meeting the responsibilities of developing and conserving some of the vital natural resources of the free world. Day and night, around the clock and around the world, McDermott is on the job, meeting challenges, solving problems, introducing new ideas and new methods. Each new job represents another step along the paths of oil progress.